Welcome, everybody, and thank you for staying so long for the Silicon Catalyst, Silicon Grapevine Live, and EE Times partnership. Actually, Silicon Grapevine started with an idea 2 years ago in the Santa Clara Marriott when I was having coffee with Rich Curtin and Tarun Verma. So I'm glad we've brought it to some level where we can actually make this an inaugural live event. So thank you for coming. And one of the things I think is quite obvious is, as a journalist, as media, we hear AI in everything. We hear AI everywhere, and EE Times runs a conference called AI Everywhere. But what I would like to do today is just talk to our esteemed panelists, just to dig into some of the transformative aspects from a silicon point of view, but also, what are we going to be seeing in 2030? But I don't know whether there are other issues that we're not considering, so hopefully we can tease some of those out. And I mean, just to give you a little bit of some context, and as a journalist, I always look at context in this today or this week, and I know this is being recorded and it will be played back forever, but in terms of what's happening, this week we had the big US and Saudi deals in AI, and I know, Navin, you had colleagues there.
With they're here in the audience.
Yes, and I've spoken to him, and some very positive outcomes there. But also at the same time, there are people who are talking about some of the challenges, and Eric Schmidt from ex-CEO of Google, he was warning. He issued a stark warning to Congress that superintelligent AI could eventually consume 99% of the world's electricity. He said to the House Energy and Commerce Committee that AI's energy demand could surge from around 3% today to nearly the entire global power grid in the coming decades. And that's not very different to what I've been seeing from keynotes at technical conferences where people like Mark Papermaster at AMD has been saying we're going to run out of energy for AI. So Eric Schmidt's messages were AI is now an energy arms race. Compute is the new global currency. Computing will require all forms of energy, renewables, nuclear, and even fossil fuels. Hopefully, in some of the discussions today, we'll this evening in the next 45 minutes, we'll get some of those addressed. But before we do that, I'd like each of the panelists just to quickly introduce themselves. I know Navin's very brief, so Navin's going to go first. Tell us a little bit about you and your background and some of the successes on AI investments you've been doing.
Absolutely. Just to be clear, what does brief mean? Like 2 minutes, 30 seconds, 50?
No. You can do whatever.
I can just.
You can do whatever you like, but I think
you're the moderator. Just tell me. I'll.
2 minutes is fine.
2 minutes. Okay. Navin Chaddha, managing partner at Mayfield Fund. Mayfield is an early stage venture capital firm which has been in business since 1969. In our history, we have invested in over 500 companies, primarily in the B2B tech ecosystem, of which 120 have had IPOs and another 225 have been acquired. The stage we invest in is primarily ideation and inception. That's 80% of our business. And then we do some investments where we are not the first money. It could be in the form of the first or the second check, if you will. But really, our business is how do we help entrepreneurs get into business?
And you were actually one of the first guests on my Silicon Grapevine episodes. So,
oh, thank you.
Yeah, and it was a very good one.
I must have done a little bit okay to be back here.
Let's go to Ravi. Ravi Subramaniam.
Ravi Subramaniam, Chief Product Officer for Synopsys. Spent half my career in semiconductor design, mobile radio communication chips, digital video broadcasting, and wireline communication, and half my career in designing better tools to be able to get chips out the door, because the chips are far short of what's required for designers to get stuff out the door. At Synopsys, responsible for the product portfolio, and probably the most seminal thing right now is Moore's Law has been driving a lot of the R&D in the electronic design automation industry, but that industry is very rapidly moving from silicon to systems and software. So we have new drivers for R&D that are really the industries that many of you are starting companies in, that are driving very, very different requirements if you're selling into consumer market, industrial market, hyperscaler market, mobile market, automotive market, driving radical changes with the advent of 3D integrated circuits and software-defined products. So really pleasure to be in front of this crowd.
Thank you, Ravi. Faran, tell us a little bit about you and Natcast and your background.
Yeah, I'm Faran Nouri, and I'm a senior investor with Natcast Venture Fund, which is called the Innovation Fund. I'm assuming most of you in this audience knew who Natcast is. In case somebody doesn't know, we're the operator of NSTC and CHIPS Act. We, as part of the Natcast, is a private-public partnership that was formed to enhance the competitiveness of U.S. semi-industry by providing R&D prototyping facilities. We have design enablement facilities, as well as now we're launching the venture fund of the Natcast to invest in semi-ecosystem and tire the ecosystem. Myself, I've been most of my career, I've spent all my career in semiconductor industry, and it's a long one, and most of it as a technologist, and as the fabs left Silicon Valley, I moved to capital equipment, and eventually when I thought Moore's Law was completely out of steam, I went to business school and reinvented myself as an investor, and over the last decade, I've been investing in semi-ecosystem.
Excellent. Just in case anybody doesn't know, I'm EE Times editor-in-chief. I've been with EE Times around 7 years, but I've been in the industry about 41 years in various roles in startups and as a mentor with government advisor, and also doing, I think, what I like to do, which is storytelling in the world of semiconductors and electronics. And I hopefully do it well sometimes. So let's go to the first question that I sort of have. And I think we get a lot of press releases, and they say about the transformative impact of AI. The question I always ask is, so tell me some detail. So from each of you, I think I'm going to ask you, get some of your views on how the transformative effects of this AI era will impact organizations and industries. There are different areas, but you're all involved in. So I think Navin is an investor, Ravi, with your customers, and Faran with your the sort of companies that come through and the investigations that you do as well. Maybe I'll start with you, Faran. Just give me a little bit of some of the examples of significant transformations you've seen and particular instances.
So I think, as someone who's always been in semi-industry, I think our modern lifestyle is really on the back of semiconductors, whether it was the PC era or smartphones, and now the AI, which is, this industry. As long as I've been in semi-industry, we've always went from one killer app to the other, and now AI is, the mother of all killer apps. It's the most dramatic tailwind we have seen in the industry. But at the same time, how we are not meeting that demand. We're not able, current technologies and systems do not meet the demand, the end demand. So this has necessitated a huge amount of innovation in the industry. And I think truly I have, as an investor, over a decade that I've been investing in semi-industry, I've never seen so many companies and so many startups. So it's the most exciting time I have seen, because the demand is so dramatically large, and the need, and we're falling so short of being able to meet that demand, that all along the ecosystem there is innovation. So,
but are there any specific instances where you've seen, like, oh, wow, this has been really transformative, or something that you didn't think would happen?
In terms of the number of startups?
No, the AI generally.
Well, I think that in our daily life, I experienced that, like going from once AI became generative AI, I think it suddenly touched our lives in a very, real way. When AI was industrial AI, maybe we didn't feel it, but generative AI is now.
It's real consumer now.
It's real consumer now. Who amongst us doesn't use ChatGPT or some version of it every day? And now if it's becoming to agentic AI now, that's more mind-boggling. But I think it's also really impacted semi-industry in particular, the way we do things as well. Very dramatically shifting the way we design, the way we manufacture all along the way in a way that's I've never seen.
Navin, go on.
Yeah, so I think if I understand the question well, right, like where are we seeing the adoption of AI
Yes.
In industries, right? So we have the vantage point of having the front row seat where we are seeing AI using agentic technologies manifesting itself in the form of digital companions, which are working with humans as AI teammates, AI sidekicks, AI coaches. So I won't talk about the consumer stuff, but let me tell you where our portfolio is. We have around 15 to 20 companies which are these digital companions. They started in software development. Now we know what the big winners there are. They also were in contact centers. You should assume in every business function where humans don't want to do the job, humans can't do the job, or there's a shortage of talent, AI is going to do it. And I'll get to the semiconductor example just briefly. So where has that happened? It started with development, as I said, happened in contact center, but now these AI teammates are in IT ops. Nobody wants to wear pagers at night. They are in security operations. They are AI performance marketing. They are AI sales engineers who do demos. But since this is about the semiconductor industry forum, we had a very interesting company launched today called Cognichip. It's Faraz, a third-time serial entrepreneur, built 2 public companies before. The thesis is everybody's talking about Cursor, GitHub Copilot. I think they built probably the best AI chip engineer in the market, which launched today. They had to invent a new LLM, what they call artificial chip intelligence. It's a physics model, and the reason the transformer models didn't work fully was if you are in the semiconductor industry, you can't go train on the internet on somebody, take one login on Forbes and train on all the content. Domain-specific data, semiconductor engineers who use the product need behavior, need context, and what they're doing is going after jobs. There's a shortage of talent, double E, and basically, I have to be careful before the stones come to me, thanks to some administrative changes with like global tensions and dislocation of supply chains, the talent has to be here, right? And that's what this is doing. Start with mundane things like physical verification, testing, right? Like let the people here do the jobs they do well. And in the chip engineering life cycle, and they're not planning to replace any of the tools like Synopsys, Cadence, they're ecosystem friendly.
Yeah.
It's an agent, an AI chip engineer, which is working with all the stuff humans do. And can you reduce, if this is happening 24/7, the chip development cycle, shrink it? Do you need that much money? And keep going faster. So I think that's what at least our vision as an early stage AI venture capitalist is. There were like 3,000 SaaS applications. They're going to be 3,000 AI teammates. There'll be some horizontal ones, which you use like OpenAI, stuff from Anthropic,
a lot of vertical.
Right? Like, but you can just imagine how can now OpenAI go become an AI chip engineer? Whose content are you going to steal, right? Like it's the.
But I think it resonates with a conversation I was having last night here in the Bay Area, and the company that's basically doing agentic AI for component selection, sensing, the simulation, and the sourcing.
There'll be many, many of them,
Yeah.
right? Wherever there is shortage of talent, I don't believe entrepreneurs in the room and outside should go and say, I'll replace jobs. Why, man?
Yeah.
Go fulfill jobs that are open. Second, like humans don't want to do. I don't want to wear pagers at night. Well, you'd go do it. But before you fix the machine, call me. I'll do that. The website is slow. Get up at night. Like response time is slow. Somebody hacked the password. Hey, I can do it.
Well,
Use it as a slave.
It'll put a few Indian offshore centers out of business, I guess.
It's global dislocation, right? Like either AI will do it or some other forces will do it.
Exactly. That sort of plays on the talent thing. And Ravi, I think one of the things in the EDA world here, I think you've been looking at is AI, using AI to do chip design to solve the talent problem. But there are many other areas. So just give us a little idea of what areas you're seeing.
Sure, I think our perspective is really starting with the $100+ trillion GDP of the world.
Yeah.
Every industry that makes up that $100+ trillion is going to be impacted by AI. And that is a starting premise for us. And in each of those industries, there are products and services. Those products and services are changing because of AI. What is a product is changing. And probably the most fundamental thing is the role of compute in every product is fundamentally changing. In some industries, they didn't have a compute roadmap in their product, which they now have to introduce. And then when you start thinking about compute, it comes down to semiconductors. So that's the, if you will, hierarchy of how we see what the opportunity is. And so a key part of that is the pervasiveness of AI, and therefore the pervasiveness of semiconductors. But what is also fundamentally transformative right now is, for a very large part of the history of this industry, the hardware-software contract has been Microsoft, Intel. Today, the hardware-software contract is so different for each of these industries. What are the software workloads, the applications, and what do they need to run on to be delivering energy-efficient compute in that environment? And that's the biggest challenge we see, which is AI will power many things, as Navin mentioned, and the role of agents will be very, very different. The world 10 years from now will be a world we don't recognize today, because there will be things, effectively agents, in every aspect of life. So coming down to Synopsys, the first piece is enabling the companies that are building these new compute solutions. There's truly a revolution in computer architecture that is tied to these new software workloads. And that is very, very important, because we see dramatic new approaches on compute and beyond GPU. And then the second is, if we look at EDA and how chips are designed, verified, and manufactured, there are many, many functions that can be optimized. So if you look at a workflow, there are specific tasks in a workflow that can be optimized. And then second is, as things become more autonomous and more learning, you can get agentic type of capability, which will actually change the workflow. And as Navin mentioned, I completely agree, they'll dramatically reduce the time it took to do something, task A versus task B. Already today, we're in year number 7 for Synopsys of seeing how you can dramatically achieve a power, performance, or area result in half the time or 1/3 the time. You can achieve verification coverage in a chip in a fraction of the time, 3x or 4x. And what that means in terms of how fast you can develop and innovate and explore is really up to the innovators here in the audience to do. But fundamentally, I mean, I'll come back to the beginning, which is AI is going to make products have the ability to learn and then do tasks. And that touches every aspect of the economy.
Interesting. And the next point I wanted to just sort of debate is when we talk about energy, I think a lot of the energy goes into the data centers, the training. But also, I mean, I've been seeing one of the data points, I think Malcolm Penn from Future Horizons put out a few weeks ago, there's a slowdown in the market for data center AI and GPUs. And in the conversations I'm having in industry, there's a lot more effort to move to edge AI. Obviously, I think that makes it more efficient in many ways, and also from latency, security, all that kind of stuff, and data privacy, and reducing the power burden. Do you think that will change the dynamics of what we see as scary figures for power demands? I don't know who wants to sort of start that conversation. And is there too much scaremongering, or is it real? And will edge AI change things?
I think that if we assume that we're just going to do AI data centers the way we are doing today, we're not going to be able to do it because we're going to hit the wall on the energy limitations. But we will, along the way, have to, and we are seeing a lot of the innovations, whether it's just photonics, whether it's different power delivery solutions in cooling, in scale-out, scale-up technologies, to address some of these huge power consumption. At the same time, this is not, I don't think it's going to be either or. That development will continue, but like Ravi was saying, there's a lot of edge compute that's happening. There's a lot of application-specific compute for AI inference that's, especially as we go to move from some of the developments, such as reasoning, as that becomes available to us, there's going to be a lot of application-specific compute at the edge. So I think these are not going to be either or. You're going to have to go on all fronts, have clean sources of energy, at the same time as you're reducing the power consumption and cooling and all that in the data center. But I think the edge inference will be moving faster, will be growing faster.
We saw today presentations like the edge sensing, and so I think there are. I think I met a company in Dubai last week. They were doing Arabic speech to text, LLM, and they can run that on the CPU. They don't need a GPU, and it's like 120 million parameters. So there are going to be more specific things, I guess.
Yeah, there are going to be a lot of specific things that,
Yeah, so to Navin's point on Faraj's company that just started, why did they have to build a specific LLM? We're going to be in a world of multi-models.
Yep.
yeah.
Heterogeneous models. The demand for compute as the model complexity grows. Right now, I would say we're in the first generation of understanding how training and inferencing parameter sets affect the power consumption of the compute needed to support it. And as the models evolve, computer architectures evolve to get more and more power efficient. Yeah. I don't think power and the pressure on power will ever go away, because as we get more and more complex models, they just consume power.
They'll be going in tandem.
I think it will be
scary. Yeah. Exactly.
Yeah.
I actually like power to be more as a VC.
Sorry?
I like it. I like it. It's a good problem.
Explain.
The main reason is, right, like in life, necessity is the motherhood of all invention.
Yeah.
I think power, cooling, distributed energy creation is the biggest opportunity. Chips, this, that, NVIDIA, 40% of the money is going into power and cooling. Yeah. Just mark my words, 10 years from now, see how 20, 30, 40, $50 billion companies get created in which this is not going to stop, right? You can go from centralized data centers to edge to Middle East. My entire team was there. You can come here. This hasn't even started.
Yeah.
If every device in the world, billion cell phones, 100 billion IoT devices will have intelligence, mark my words, energy consumption will be 10x of what it is today. And that's where, when that happens, who wins? Entrepreneurs. So I would push the people that, yes, And, you know, we're not dinosaurs as a society. The amount of innovation which is happening in alternative forms of energy, the world isn't going to stop.
Yeah.
Same thing, x86 Valley built by Intel. What happened? Two things happened. One, the mobile, different architecture was required. ARM won, 30-year-old company. GPUs, floating points became example. So, you know what? Everybody has a Rome moment.
Yeah.
And when these power requirements would come today, we know better, like you guys know better, power is a very important thing along with performance. I think the players 10 years from now may not be the same. And people who sell picks and shovels will keep winning, right? And the reason is, right, that's what Silicon Valley is about. Like I go talk to public company investors, say, do you own NVIDIA? No, we don't own it. What do you own? Number one holding is ASML. Do people know who ASML is?
Yeah.
Number one holding.
This crowd knows. Yeah.
Right? Like I asked them, right, like what's the number two holding? TSMC.
Yeah.
And number 3, Carl Zeiss.
And I won't say after that because there's some people sitting here whose stock might go up. Because I'm saying if you're a picks and shovels provider, trust me, there are 10 power regulator companies. There's 100 companies solving cooling on air, on liquid, on cold bond. I can't even pronounce the stuff. When that happens, you realize the market has discovered a problem. Floodgates have opened. I think it's not only silicon. Basic scientists, what they have already done with models, now they're going to go, their time has come. The people who used to be in Silicon Valley 50 years back, 30 years back, airplanes, they were doing this thing. And these data centers consume power like there's no tomorrow.
Yeah.
Like each chip, right? Like I was reading, I'm not up to like 40 amps, my Tesla charger. I look at this and say 10,000 amps. I'm going, what is this? Right? But can somebody, I see pitches every week. There are companies trying. We have a company which figured out an inference model, which is 1/10 the cost and 10x the speed. So transformers will be used for training. The moment you go to inference, who thought there'll be another model? Same thing might happen. The edge chips might be different, right? So to me, it is, I agree, it's unsustainable, but I love it. Because when it's unsustainable, humanity is not going to sit tight.
Yeah.
We know how to take every minutia out, and who knew our lives will be this,
Yeah.
right? So I'm an optimist, right? I think it'll be a massive area. It'll keep failing, but it'll get solved, right? Like everything gets taken care of.
And I think we've seen that over the history of the semiconductor industry. So I think there's always been some innovation that's just moved it a notch up.
Yeah, and my only point is the companies who win in a certain revolution, history has shown again and again, besides TSMC and ASML, new players happen. x86, ARM, and just the fundamental, they're different. Who knew? Who will be the first $3 trillion company in semis? Who will be the second one?
That's why as a VC, you want to be in this space. Seriously.
I love it.
It's just,
I think when a tornado market is happening, right? Like you have to just be open-minded and say, okay, let's go read physics books now. Let's understand what I studied about nuclear energy. Time has come back, otherwise I'll get duped. Everything is okay, not getting duped.
Yeah, I think.
So literally, somebody is making I invested some nuclear portable storage. I said, what is this? You're telling me you don't drill? He says, yeah. I said, okay. Now what do I do? I'm just saying, people are doing all kinds of stuff.
yeah.
I think you're in amazing front seat, and fortunately, I'm also.
And I joke about these things, as you know, right? Like it's just, it's good. Problems are good.
Yeah.
Right? Like it keeps us going.
Yeah. But you know, I think you probably answered this question already. But if there's something specific you want to talk about, Navin, you said the real opportunity in AI infrastructure lies beyond GPUs. What are the areas that you are seeing that most exciting to you right now?
Yeah, to be precise, right? Like the GPU existing companies, big, small, that TAM is the biggest. My lens is early stage VC. As I said, we only do first and second round of investing. So we see a major supercomputer has been built by the most successful company of the last 5 to 10 years, NVIDIA. It's a vertically integrated supercomputer, right? And I'm looking at it and saying, okay, Devan GPU have 90% of the market. What is the problem? Power cooling, that's not their forte. So can you be arms merchant into this thing? Connectivity. On optics, we have companies we have funded which on copper have figured out how to do 1 terabit per second. Transceivers, global supply chain in China, you need a US company. So we are going component by component, scale out switching, scale up switching. I'm back, I'm a EE. I'm back to my late 80s, early 90s books. Luckily, I still have them. And they're still offline in some boxes.
Yeah.
So I think you have to just look apart. Where is the bottleneck? And the good news is we are not starting companies. By talking about it, by coming to places like this, the expertise is here in the room. Just applied into a different problem. Just so happened nobody cared about it. It was like saying 10 years back, software has eaten the world. There's no need for specialized ASICs, and x86 wins. And we know what happened, right? Like,
yeah.
So to me, the hardware era is back. It's the renaissance of silicon. And people, I want to congratulate. How many people are from the semi industry here? Awesome.
This is
I think this is your era again.
required.
Like silicon is coming back to Silicon Valley. So I want to like applaud you guys.
This is a Silicon Catalyst event. So.
in Silicon Valley.
Catalyze, I'm ready to write checks.
Yeah.
And he's ready to supply the tools. We'll get something for free from him today.
Excellent, excellent. You talked about x86 being superseded. Is there a role for things like RISC-V or any other areas? You talked about photonics and silicon photonics.
Yeah, lots of stuff. I think RISC-V, we should ask Ravi, right?
Ravi, yes, go on.
The reason is, right, the ecosystem, but I want to learn more. Like, we have companies in there, but the ARM ecosystem is so far ahead that at least we haven't seen it beyond, like embedded systems, get into the data center. But you guys have a front row seat, right? It's not, conceptually it makes sense, but the adoption hasn't been there. But
Infineon have just taken on the RISC-V processor from Synopsys, the IP, and I think that's going into the automotive sector.
I think the perspective to have on RISC-V is in the insatiable demand for efficient compute, what's needed in which application, in which market, in which products. And today, there are, I think in our estimate, probably about 4 to 5 billion RISC cores shipped every year in the world, and rapidly growing. The main applications, exactly as Navin said, in embedded applications where you do not need an ecosystem.
Yep.
And in such a case, you can have a company that's captive in its application of RISC-V, consumption of RISC-V, and running workloads on RISC-V. And you don't need to create an ecosystem and support one to the external world. So if you look at the world of compute, CPU, GPU, XPU, NPU, pick your favorite PU, as we call it, RISC-V is one of those.
Yeah.
ARM is one of those. And fundamentally, where we see a need for an ecosystem, you see certain decisions. Where you see need for an embedded application, you see certain decisions. And it varies industry by industry. But just here in Silicon Valley, 2 companies, Meta and NVIDIA, have been very clear about how they are shipping products with, and billions of RISC-V cores. And the question to ask is, well, why did they do that versus something else? And ultimately, it really comes down to what type of compute do you need? And when you start thinking about compute, you talk about efficient compute. What type of power efficient compute do you need? Do you need the power of instruction sets that are optimized for workloads? And if you're not needing to support a broad ecosystem, you know your workload well, you know your compute well, you can optimize the heck out of it. And so RISC-V that's how we see it evolving. And in many different industries, there's a different driver to use it. And I think the rate of diffusion, if you will, is very, very different in many industries of RISC-V. So it's not equally growing in every industry.
But I'm also hearing always that it is for certain things in the system. And now we talk about 3D chips, and you're talking about maybe using different architectures, different heterogeneous architectures. So it's not always just one or the other anyway.
Exactly. And in many systems, you will see many CPU vendors in there.
Exactly. Any comments?
No, I think you're the expert here.
No.
I think you referred to it earlier, Ravi, but I think one of the things about AI is it's not just a singular AI revolution. There's multiple S-curves rising in parallel. I think we've talked generally already about sort of how silicon and AI are co-evolving, but are there any comments on specific areas where the AI and silicon are co-evolving?
Absolutely. So one of the most amazing things about this point in history is you design tools that are used to design chips that do AI, that are then used to improve the tools, to create new tools, to then create new chips. So it is a very virtuous circle. And because place and route is very different than verification, is very different than software security testing, each of those applications drive a very different evolution for AI just within the EDA industry.
Synopsys could make a movie, you have a studio, you could call it The Lion King Circle of Life.
Yeah.
Actually, I think the S-curve multiplicative factor is nice because Navin could benefit from looking at that map, because that's really pointing the infinite potential of what can happen, because this type of cycle has not existed in the industry in its history. Yeah. For a lion's share, it's been really based on using a von Neumann architecture to run EDA tools. Yeah. And run your software security tests or your safety testing tools. And now, based on the nature of the problem, you can actually develop an LLM. And that creates an opportunity to create a virtuous cycle just for that particular problem.
And it's not, it's not just on the design side, it's manufacturing
exactly.
and tool development
Yes.
is similarly impacted, which is shortening all those cycles, which have
exactly.
historically been so long. But,
And then earlier, Navin, you talked about the power, cooling, interconnects, and all that as well. So that all plays into it, I guess.
Yeah, I think this innovation, as my fellow panelists have said, is happening everywhere, even though there was plateauing of Moore's law, right? But if you look at LLMs, they're getting faster. They're getting cheaper, right? The cost per token, if you look at it the way it's going, so now this S-curve thing, right? Actually, Moore's law is happening in everything else around,
yes.
besides the CPU. But look at the Moore's law on the GPU, what it's doing. When Jensen comes and announces 4 generations, right? Like, you go like, why should I buy this generation?
Exactly.
wait a few minutes.
Yeah, and I asked him, right? Like, and I don't know if people know the answer. He said, it's a simple message I give my customers. If you wait for 3 generations, you'll be out of business. Because if you're, it's true.
Yes, we're all right. Yeah.
Right? Like if you're not, I have this, use it, you'll get to there. So it is what you started with. It's AI everywhere. It's essential. And in certain industries, it's going to be the race to the bottom if you don't use this.
It was just like the initial stages of the mobile phone, every 6 months you had to...
Or it's like the internet, right? Yeah. Like you can't sell online. You know what happened to the bookstores and this store and that store.
I was thinking as this multiple S-curves, I was just thinking of one of the companies we're now looking at in life sciences. And they are the S-curves of, the personalized medicine,
yep.
Big data, there's a lot of multiple things plus silicon all converging to do something very dramatically different.
Yeah, and I think one of the big things I should have mentioned earlier, I agree with what Ravi just said, right? Usually, having been around the block since the early 90s, PC, internet, mobile cloud, there's usually a 10x inflection, either on the back end or on the front end. And here, there are like two fundamental things which are happening. First, the interface changed. It's a 10x disruption. It's not a browser, command line. You speak your language, machine understands you. Till now, we have been slaves of machines understanding their language, and they keep changing.
Yeah.
Sometimes it's assembly, sometimes I'm told it's C, then it's C++, then it's Java, then it's some other thing, right? But now you just speak, and it does all the work. Beautiful. And then because of the S-curves we are talking about on the back end, intelligence is available on demand. And I don't know, you said it, right? Like that basically, now machines not only can understand our language, but the multiple S-curves are, they can think, they used to think before, but now they can take action, which humans also do, right? So now, this is collaborative intelligence, right? It's 100x,
Yeah.
right? People were worried that 20 million programmers, they'll shrink. My think is 8 billion people will be programmers and creators.
Exactly.
I think everybody now, with some of the companies we are funding, can use your tools. Right? Everybody should be a chip. Why do you need to know these details?
So I'm going to move us on.
No, I'm not kidding. Agents will be using our software.
I'm completely aligned with that view of the future. It is absolutely, it's starting to happen already.
Yeah, today, there was a New York Times article, one of our companies, Walmart, headlines in Wall Street Journal says their new customer is not human, it's an agent. Our company, exactly. Yes. Agents are coming to your website because I go tell them on OpenAI, hey, find me the best.
Exactly.
So people are going to Expedia, it's not humans. Agents are crawling.
You know, I saw this, and it's actually a very good, discussion we're having now. There's an interview on Charlie Rose with Jensen Huang about 20 years ago. And he said, you know, what's happened so far is we took a typewriter and we made Microsoft Word. That's what x86 did. We took a calculator and we made Microsoft Excel. That's what x86 did. Now we are starting to look at pictures and draw pictures. x86 doesn't do that very well. So that's what the GPU is doing. And if you just think about that era, how many gaming companies there were in Silicon Valley doing graphics chips? And what was happening then? And then you kind of fast forward now, and then you say, well, now it's actually starting to learn. And what do you need for that? And then you're making decisions once you have learned. And then you're taking actions. And pretty much, you're literally creating intelligence. And that's really what we're in the middle of. But it's the creative destruction of many industries as we go along.
So I want to cover two points before we finish, because I think we'll be running out of time. One is Silicon Catalyst event. For founders building in silicon systems or AI infrastructure, how should they think about timing, differentiation, and where to focus in such a fast evolving market? And I think maybe Navin is a good person to start there.
And this is in like which layer of the stack or which sector or?
In sort of in any layer, really. If you're looking at
investments?
If you're looking at the companies here, what should they think about timing?
Yeah. I think like we are in a very, very early innings. But what I would like to say is the hype on valuations is through the roof. The adoption is early. But I just want to bring some facts to the table, right? Like, let's look at what did it take to get 100 million users on any technology, to have 100 million PCs in the world. Microsoft started in 1975. I was there in the mid-90s. Till 30 years, it didn't happen. 100 million PC, a PC on every desktop. The web browser to get to 100 million, 10 years. Mobile phones, smartphones, 100 million, maybe 3 years, 4 years. TikTok, 9 months. OpenAI the same week. So if you can come up with a killer app where you don't have to sell to a human, that's the adoption of this technology. And fundamentally, right, like how many people have heard about Ozempic? It's not from this industry in Silicon Valley. Have you guys heard about Ozempic? Right, like it's printing money. The first medicine, I don't even know what they charge, like $1,000 an injection or something. And then I won't talk about the other medicine which comes. And this is an intelligence tablet. If you are not going to take this this is intelligence as a service, as a business, and as a human consumer or professional, you don't endorse it, you're going to be in trouble. It's the dinosaur moment, right? So to me, you have to get on this. I don't know how long it will take, but I'm convinced in certain areas, you're going from 0 to 90% penetration in less than a year. It's just happening. If your value prop is that strong, but some other areas, if you pick the wrong problem, it'll take 10 years. Then you didn't solve a pain point. That's where the whole picking for VCs, entrepreneurs and companies like you is, there's so much opportunity. It's black magic. How do you figure out which thing is going to inflect like this? And in our portfolio, the inflection of companies, SaaS companies, the metrics we are seeing is 5x accelerated. And the orders of infrastructure companies, we don't have 1, 2, 3. If you're selling hardware, if you get the right product, right time, first year of revenue is $100 to $200 million. Next year is $500 million. Third year is $1 billion. I don't have one such company. And it reminds me of the 90s when the telecom infrastructure was happening.
God.
Telecom, that was under C fiber, I'm going to put DSL, man, you put it once. Every few hours, you're putting those wires. That's the speed at which centralized data centers, edge data centers, and wait till it comes here. This thing will have to be redesigned. So the pace at which this is happening, none of us are just used to this pace. And for software companies to grow at the same point, that's where I'm seeing slower adoption, because first agents have to happen. But right now, we are just building the infrastructure. The factories and the roads are being built. The cars have yet to come. So the bottom layers are going through astronomical growth. The actual cars, build the roads, they'll come. So Ford, GM, like there's time for them. Those are what I call the apps. This is the time of picks and shovels providers. The infrastructure, the roads are being built. Now, turns out the most successful company in the world is in Silicon Valley. You know what they provide. You can't build the road without them.
Yeah. Any other comments there? No. Okay. So one of the last questions before we sort of round up. What do you see? I mean, we all talk very positively about AI. What are the threats or things that we need to be concerned about regarding AI? And is that something as entrepreneurs, investors, companies like big companies like Synopsys and others should be concerned about?
So, like any technology, I think as it gets created, there are many uses. And ultimately, the use of a technology is, I mean, fundamentally, you can say governed by, is there a ethical basis for using a technology or not? There will always be bad actors everywhere. I think the intent and the way technology grows to advance economies and humankind, I think we had a discussion earlier, right? Is AI evolving to serve shareholders, serve solving problems, or serve bad actors? And you could say it's doing all of that at the same time. And in different industries, there's the opportunity for AI to advance the state of what is present there. Let's take the security industry. AI used to both synthesize or create synthetic threats, and AI being used by bad actors to attack. And it then comes down to a battle of compute power on how much compute is there to drive AI. So I think we will see bad actors in AI in different industries. That's a matter of fact.
But you also have companies in the Bay Area, I've met, who are using AI to counter those bad actors as well.
And so that's going to be the new, you can say good intelligence versus bad intelligence, but it's going to be a mirror of humankind, I think.
So last week in Dubai, JISEC, it was a security conference, I was seeing these AI versus AI battles, and it's quite fascinating, like the bad actors and the good actors.
Indeed.
I mean, I don't know if you have any comments on sort of things we should be watching.
Think to me, I agree, and I think I'll have similar views to everybody. My biggest worry is actually being in the place I'm in the US. We can't lose this race. Basically, intelligence is the new oil.
Yes.
It's being mined like crazy. This is not about nuclear weapons and stuff. If you win this race, as a company, which we are seeing what NVIDIA did, the difference between number 1 and number 2 is 10:1, 20:1, 30:1. As he rightfully said, there are issues with everybody. I'm more worried about human-to-human fighting. Machine-to-machine fighting is okay, right? And machines, right, will fight with humans, but my point always is then don't use it. Don't pay for it. People are worried my jobs will get taken over. I'm the CIO. Gamil is here. Don't use it. No, I'm just saying, so that's what is going to happen. Humans are pretty smart.
Yeah.
It's a tool. We'll use this thing. So that's one of my worry. We can't lose this race. And secondly, the fear of job loss, fear of AI being bad, it's the horse. We are the jockey. Ride it. Take control of it. And if humans do that, it's like nuclear energy. Set regulations, set guardrails on where it can be used. If we don't, it can do anything.
So that's but that's the point, though. 2 points that you made, actually, I think I agree on both. A, we can't afford to lose this, which plug for Natcast. That's why we're here, to make sure U.S. competitiveness in semi-industry. Secondly, though, to your point of AI is the horse, we are riding it, we need to make sure with something so powerful that our institutions, our laws, our policies are going to catch up with. We're not going to get way too ahead of, if the horse is running wild and the jockey is falling off, then that's not that good either. But so it's the concern is, are the institutions catching up with this?
I agree, and that's why organizations like you at this time are critical, both on American innovation, but we need more, because people are worried about regulation, man. There's regulation in everything. You jump a stop sign, you get a ticket. You drive. So what is the problem? This is a machine, regulated, man. Just tell me what can it do and what it can't.
I can't
Humans
drive.
are regulated every day. Forget about, right? I'm just saying you jump a stop sign, it's a crime.
Yeah.
I didn't see it.
Yeah. So one thing that's really been interesting for me in this last 5 years is, as people see, oh, there's an AI-powered tool, or very often we see companies that say, oh, well, we can't use AI. We're not allowed to use AI in the company. And for me, it's fundamentally an equation that Navin just described, which is there are all these things that may be happening or might happen, but the cost of not adopting.
Yeah.
And will you be around if you don't? And that's really, I think, a very fundamental equation.
I agree, and then VC smiles. We already funded 5 companies which solved that problem too. So, literally.
Exactly.
Why can you be afraid, man? It's a security problem, right? When people start going to the internet, you needed firewalls. It's yet another firewall.
Yes.
So just go fund it. It's the same movie played again and again and again.
Yes.
It's entrepreneurs.
You've seen it a few times. I'm going to close this now because we probably need to finish soon. I'm going to ask you one question each now, each the same question, which is, what do you see in terms of how the world will look like as a result of AI by the end of the decade? And also then just close on what sort of final message you want to give to our audience here. So who shall I start? Who wants to go first? You're on. Go.
Okay, well,
So world in 2030 and closing message.
you know, in 10 years, I think I don't even know, things will be so different that I'm not even sure I can imagine it. I think the biggest changes may come around health and life sciences, ways we treat disease or diagnose disease. We may live too long, I don't know. But, and also in robotics, for example, these are the areas that are very interesting to me. And robotics, as well as autonomy, that will change our lives. I don't think we're going to be driving ourselves. I'm looking forward to robots in my house doing the housework, you know. So, and elderly care as I deal with relatives and such. I mean, I just imagine that all of that will be really different in ways, and a lot of it will be in ways that we are not foreseeing, I think.
I don't know if it was in all cultures, but in England, you used to have butlers in the 18th century.
Yeah.
Robotic butlers.
You know, I just a couple of weeks ago came back from Istanbul, and I was haggling in the bazaar, and every shop, they would hand you the Google Translate, and that's how you haggle in the bazaar now. It just blew me away, you know, so.
Yeah. Ravi.
Yeah, I'd say
2030.
2030, the way we will interact with people, the way we will interact with work, the way we will interact with machines will be completely transformed because of agents. What we do, how we talk to our doctors, how we talk to our gardeners, how we talk to our grocers, I truly believe that will be completely changed. And I also think in 2030, if we look at the percentage of the worldwide GDP that's generated out of AI factories, will surprise us. It will be a very, very large amount, and it'll be because each of these industries are transforming. Closing thought to this theme, you know, if we think about the theme of intelligence being pervasive, we're probably at one of the most exciting times in history. We're in the first innings, as Navin said, I agree. But there's an opportunity for every entrepreneur. There are many, many problems. Finding the high-value problem is now a very different question. The high-value problem is not something that was maybe so obvious as it may have been in the past. So finding that high-value problem, and velocity is key, not speed. Velocity it's not a scalar, it's a vector at a magnitude and a direction. So finding that high-value problem and moving with velocity is critical because that's the way value is created right now.
Thank you. Finally, Navin.
I think lots of things will happen. I think we should just keep an open mind. And 40 years back, 30 years back, we used to watch these movies, Back to Future. I think time is back to dream, right? Star Trek, it's a reality. Who knew? So my feeling is don't have a prepared mind.
Sorry,
Don't have a prepared mind. When you have a prepared mind, you say, this is what is going to happen. I actually have an open mind. I don't know what's going to happen. I think entrepreneurs will come pitch and something will click. When we did like Lyft, Poshmark, these investments, they didn't make head or tail sense. I think that's what is going to happen now, that you need to have a beginner's mind, that anything is possible, forget what, and then second, AI and human skills will fuse. We are in a fusion era. You won't even know where you're using AI and when you're not, right? ChatGPT is a good example. It makes all of us 20% productive, 30% productive. Have people done what it can do? And that's an agent for your personal and professional use. So we won't even know how basically AI integrates with human. And I actually came up with the word every time today, right now. And I'm going to now get stones or people will say, he made a point. I think we are entering a humane era. And what I mean by that is humans win. They will eat AI, HUM, brackets, A capital, I capital N. So I think that's the era we're entering. Humans win, they eat AIS pills, and they become superhumans. So that's what is going to happen, like which happens with the stuff. So that's my prediction. It could take 5 or 10 years. Humane. We are entering the humane era, where AI doesn't eat humans.
We heard it here.
Right?
The AI.
AI eats humans and says, now I'm feeling good. I'm an optimist, right? Like, I don't know how people feel about that. I feel great.
Well, thank you all very much.